Ladies and gentlemen, it will be now time to start again this next session. So I invite all participants to come and slowly sit at their place, and we will start slowly into the next part of the presentations.
Yes, yes, yes.
I don't want to say that Transport Canada is delaying FAA presentations.
If you have only one, huh? Only one, huh? Oh, yeah. Okay, okay.
And we will start soon. Wait 2 minutes, I think, for people to sit. Okay. Je le fais monter sur. Yeah. Yes, I think now we are starting to get ready. Please have a seat. So I'm glad now to be welcoming on stage please. Yes, I'm glad to be welcoming on stage Larry Kelly from FAA. He will present on the subject of the air transformation and an update on regulatory and policy from the FAA perspective.
So thank you for this tremendous symposium again. It's great to be back. Two topics that you've heard before, but we have some significant updates to offer on both of these. Talk about the air transformation and also the regulations and policy, the updates that we've done. Air transformation, if you've heard that term and you're familiar with the FAA, you may think of that as a reorganization initiative. And to some extent it is, but we also have some reasons for doing it. So I'm going to give you a couple of slides on that, and then also, we've got some significant updates on our regulations and policy. We're making some progress on both of those fronts. So this is the only slide that talks about why we're doing air transformation. We've got a website that gives you a lot more information on that if you're really curious. But I just wanted to hit a couple of high points and give you one slide on why we're doing air transformation. First, there's obviously industry growth, growing at a tremendous rate. Globalization of aviation, products are not necessarily designed and manufactured in the same place anymore. You've not got just worldwide suppliers, but you've also got the manufacturing going on in other countries. So we need to learn to leverage our other authorities in helping us doing supplier audits and those types of things. And by the same token, we expect them to be asking us for technical assistance as well in the globalization of aviation. Heightened expectations. The public, at least in the U.S., definitely has higher expectations of the FAA. They want it fast and they want it right. Technology is advancing so quickly that by the time the regulator gets there, it's too late sometimes for whatever service you may need, and that's simply not acceptable. So that's another reason we need to learn to respond more quickly. I mentioned the things changing quickly, the velocity of change. Some of the products we're seeing, we're not sure whether to call them small airplanes or rotorcraft. We're not even sure what they are anymore, quite frankly. They're just aircraft vehicles, and so our old organization, which no longer exists, of Rotorcraft Directorate and Small Airplane Directorate and so forth, isn't going to work in the future, we don't believe. At least it would require some major changes. So we need to get ahead of the new technology and advances and be there when you're ready. Okay, this is kind of a for reference only slide. This shows the old organization, shows the directorate system that we used in the past. You're probably familiar with this. Over on the let's see, on the far right, you'll see the Rotorcraft Directorate was under Lance Gant. And he covered rotorcraft policy and regulations and so forth, but he also had some manufacturing inspection district offices reporting to him, as well as a couple of ACOs and then a technical administrative staff. That's now changed. This organization structure no longer exist as of July 23rd of this year. We completely changed our organizational structure to something new. And this is current as of today, and I say that because we're continuing to evolve the organization. This is called realignment. You've got the head of the organization is Dorinda Baker. She's got 2 deputies. David Hempy has been there for quite some time. You'll see Chris Carter over on the right side. Chris Carter was made the deputy just about 2 weeks ago, so he became official. There's a reason that's in blue, so you can notice that. Then you've got the other divisions down below. These are the functional divisions. Just a couple of things to note. Maybe I'll walk through these right quickly. Organizational Performance Division, that's basically kind of an internal QMS type process where we're looking at what we do and how quickly we deliver products and services, how good those products and services are, and then we're making adjustments as we need to. We also have the International Division. I'm not sure that will continue to be there, but at least for now it's part of our realignment. Policy and Innovation Division, we have a new director, Mike Romanowski. Mike comes to us from commercial space integration, and so he's in some extent he's new to aircraft certification, but he's had a number of positions, executive positions with the various associations in the private industry, also in government. He's worked with the White House Technical Advisory capacity, and he also is formerly at one time in his career, I'm not sure exactly when, Paul, maybe you can tell me, but he was product and certification director, yes, at Sikorsky Aircraft, and also before that I think at Pratt & Whitney. So we're going to claim him as a helicopter guy, so we'll put that label on him. He's new to the position as of a week ago yesterday, in fact, he's new to the position. So great to have Mike on board. I think he's going to be very refreshing for all of us. We become trained in the way we do things, but Mike coming in new, I think is going to be good for the service and for the FAA and obviously for the industry. Compliance and Airworthiness Division, that's headed by Lance Gant. Many of you know he was the former director of the Rotorcraft Directorate. That includes all of the ACOs, so that's a significant span of control for Lance. Got those across the country. There's also one change I should mention in terms of compliance and airworthiness. All of the flight test personnel within the Aircraft Certification Service now report to Lance Gant, compliance and airworthiness. So the 3 flight test people that I had within my small branch, Rotorcraft Standards branch, they now report to Lance officially, but in fact, as we go towards refinement, they're on full-time loan back to my office. And then enterprise operations, that's where we look at budget, training, those types of things. System oversight, that's the delegations and so forth, including the MIDOs. Okay, this is the end state we're trying to go to, the functional division end state. These are the 5 big divisions that we'll be having. I can't say a lot about these other than the Policy and Innovation Division. Let me talk about that. That's where my office is currently located. Those charts underneath will change. We're not sure exactly how. But the whole responsibility of this group is to get ahead of technology. We need to be ready when you're ready, so we're going to invite people to come in early. In the past, you know, you had to have an application before we could talk to you and spend money and all that type of thing. That's not going to be the case anymore. We want you to come in early with whatever new innovations you have so that we can develop the policy and guidance in advance. Talk a little bit about the Rotorcraft regulations and policy, give you a little update. You've seen some of these slides before, but I think you'll be interested to see that we've actually made some progress and issued some regulations and policy that we think will help the industry. Some of them will help the industry considerably. This ARAC Rotorcraft Occupant Protection, to me, this is the biggest safety initiative we probably had in decades. You heard Trevor make some remarks earlier this morning about we have aircraft out there that are continuing to be produced, but in fact are not updating their actual what they're compliant with in terms of the regulations. We found that to be true. We've had previous presentations about occupant protection. We presented the data. You can refer to Lee Roskop made an excellent presentation, I think, at the 8th symposium, so take a look at that. It will show you the case for safety, for making this change. So we formed this ARAC working group back in January of 2016. They're making progress. They're making good progress, in fact. They gave us their first product was in December of 2016, and they talked about the occupant protection standards being effective, which is something we think we knew, but it was good to have industry actually look through that and take the time to look through that and confirm that. But they may not be cost beneficial for newly manufactured rotorcraft, not as a whole. So that was their initial conclusions. We then defined another task in January of 2017, earlier this year, and we asked them to tell us which portions of the occupant protection standards can be adopted within 3 years for newly manufactured rotorcraft, and then look at full compliance within 10 years. And that goes to the I guess the way we think this may come out is we have a regulation, I think it's 29.2, that talks about retroactive requirements, and the only thing that's there right now is shoulder harnesses, where aircraft produced after a certain date must have shoulder harnesses. That might be a way to do this, to actually update the standards for newly produced rotorcraft. Someone, maybe it was David, not sure, it may have been Trevor, but mentioned that we've got a regulation out there that's 25 years old, and our fleet compliance is around 10%. When it comes to blunt force trauma, I think it may be a little bit better. It's like 16%, but that regulation is also 20 years. So the technology is effective. We've seen it to be effective in our autopsy studies, but it's not getting incorporated into the field. So ARAC did give us an interim report June 8th, and that basically concluded, these are interesting conclusions, that and it only regards the crash-resistant fuel systems for newly manufactured rotorcraft. They found that partially compliant crash-resistant fuel systems are effective. And so we're kind of expecting a recommendation that would not necessarily recommend full compliance, but something along the partial means. It's not necessary to require that newly manufactured rotorcraft meet all of those crash-resistant fuel system requirements. The final report we expect to be presented to us in January of 2018. They are going to make that date, it looks like. And so we're looking forward to that final report, because that would include both crash-resistant fuel systems and also what we need to do with blunt force trauma. And then the next 6 months, and they will not require any additional tasking from the FAA in order to do this, they will be looking at what can we do back to the existing fleet. And to me, that is so key, because we can do something about newly manufactured rotorcraft, which is important, but in fact, we've got about a 1 or 2% replacement rate per year. It'll take forever to make any real gains in safety if we don't also address the existing fleet. So you can find more information there at that website, and I must hurry along. Also looking at bird strike, we saw some dramatic increases in bird strike in 2009. Some of that is due to underreporting probably in previous years, and becoming more aware of what is actually needed in that area. And you can find some great information at that website shown there. And I think there will be another presentation later in this symposium on that, so just consider this an overview just to whet your appetite. I will say that I'm expecting a really great presentation. Don't miss that presentation on bird strike, because whether or not you're interested in regulation or not, there's some operational information there that you can use, I think, now to fly safer. So please be sure and make that presentation. This is another slide that's old, but we got some great news to report. We took a look several years ago at retrospective rulemaking, and that was basically an edict from the president, executive order from our president, that's to look at rules that are being burdensome, that are unnecessary, that are obsolete. So we did that. We looked at special conditions, the equivalent level of safety findings, exemptions, and so forth, and we came up with a list. And this is that list, and we have finally managed to publish the NPRM. That was published on November 1st, 2017, so comment period closes soon. So take a look at that if you'd like to comment on that regulatory activity. Keep in mind, there are some changes, some additional changes that we would have loved to made, but the idea was you hold the line where you are now. You're not to increase standards. We're also not looking at decreasing the standards either. So we're taking what we've had in special conditions, equivalent level of safety findings, and so forth, and actually codifying those so we don't have to go through the administrative process and also burden industry with the same thing. So take the opportunity to comment if you'd like. Just keep in mind that we're not attempting to increase standards. We had some other activities that were identified out of the rulemaking retrospective look, and one of those included search and rescue. That one is, we've delayed that one slightly. We didn't want to put all the eggs in one basket. We felt like that one might take a little longer, but we have issued a number of special conditions, basically all the same, cookie cutter, on search and rescue. So we're also intending to codify those at some point. Two other regulatory activities that we're looking at are the 30-minute all-engine operating and also anti-collision lights. There's a regulation that says they must be red when, in fact, for years we've known they can also be white and be effective. So we will allow both red and white anti-collision lights. That package is basically complete. Unfortunately, we don't necessarily have any priority within the regulatory system, but we've sent it to where it needs to go for the next step. So that one's also done. Trying to keep one eye on the time and one eye on the slides here. So pilot compartment view, this one has been a really interesting one. There's a supposed fast-track new process that we were asked to exercise to do a spot rule, single program office tool. We issued the NPRM October of 2016, finished public comments in December of 2016, and it is now, some good news I think since this slide was actually made and sent to YASA for the symposium. It appears that we will be able to publish that maybe by the end of this calendar year. And this is one of those things where it kind of got caught up in some political issues at the beginning of this 2017. We had a new administration, new executive orders, very well-intended executive orders that said if you're going to put a regulation on the books, you must take 2 off. It also stated that we weren't going to burden industry, so they kind of had a banking system where you had to say if we're going to cost industry money, we're also going to save industry money. This is an odd one in that it got looked at very closely because it saved too much money, which is odd. But when you think about it, we were kind of being looked at as are the numbers real? Because if the regulation is applied as it reads now, where you have to do flight tests for your avionics and stuff, in every case and every change you make, it's extremely expensive when you look at putting the aircraft in experimental and so forth, and insurance costs. So this will save literally millions of dollars, we believe, over the next several years. So this is something that we hope to have published very, very soon. Part 2729 rewrite, I'm not going to speak a lot about this one. There was an earlier question on this. All I can tell you is that the Gamma and ASD are looking at Part 2729 rewrite, plan to make a recommendation to the authorities soon. I'm not sure exactly when. Maybe before the end of the calendar year, I'm not sure. No? Okay. Early next year, maybe. I see some shaking heads out there, people that should know. The policy for systems and equipment, again, there's going to be a later presentation on this. Let me just say that we believe there's an opportunity with the personal private and those aerial application and instruction where we can save some lives. Those 3 segments make up more than 50% of the accidents we see in the U.S. And we believe there's a way to get equipment in there without a regulatory change, because our regulation, thankfully, is performance-based and it's not specific. We think there's a way to get some safety-enhancing equipment into those aircraft without a regulatory change. We think we can do that by policy. Word of warning, perhaps, on this. This is, that policy statement has been issued. If you've got a U.S. product you want to use this on, that's great. It has not been accepted by Transport Canada nor by EASA. We're having discussions. We'll continue to have discussions on that and see what we can do to gain acceptance and whatever we need to do to make that something that be used universally. But right now, you can use this if you're in the U.S. IBF policy, again, there will be a presentation later regarding IBF policy specifically. This just kind of gives you a little bit of information. We found that performance is a challenge, I think, for inlet barrier filter modifiers. It's difficult to get a hold of the engine installation manual, for example, where the inlet distortion limits are specified, so it's difficult for them to do the testing. So we challenged the SAE S12 committee, the Helicopter Power Plant Committee, to do 2 things for us: to look at finding alternative methods for determining power available, and also to substantiate inlet distortion. So they're working, they're making good progress. They've met a couple of times face-to-face. Most recently, they had a telecon on the distortion, so I've participated in some of those, and I know that they're making progress, but it's not an easy task, and you'll hear a presentation later in the symposium on inlet barrier filters. And I guess we're not taking questions right now. We'll let's see, 18.09, that's pretty good. Okay, very good. So thank you.
Thank you very much. So now, another topic, important topics from Airbus Helicopter with Gilles Brugnot and Eric Ferreira da Silva, fleet safety, Airbus Helicopters, and the head of design. A very key topics because from years now we are still working on a very difficult subject. Juliette Fox.
Merci Jean-Marc for the promotion. Head of airworthiness only, so head of design organization is another person. And hand over to Gilles.
The same, I'm head of aviation safety for Airbus Helicopter. No more fleet safety, but aviation safety encompasses the global aspect of aviation safety. It's a joke. I want to introduce the topic. It's a hard topic. I think I will remember all my life this day of April 2016, where we had the accident of the 225 LNOGF. It was a tragedy of course, for the passenger, for the operator, for the whole oil and gas business, and for the whole Rotorcraft community. It was also a tragedy for us, because seeing a rotor flying in the air like that, it was horrible. So we reacted strongly, and we have decided to now, we are at a stage where we know a lot of things, and even if the accident investigation report from the AIBN, so the Norwegian Accident Investigation Board, has not been finished, today it has been accepted by AIBN and by EASA that we put in the public domain a movie trying to explain where we are today on this accident, on what are the possible way forward. So this movie is available on the YouTube, which you can find it if you have not seen it today. We will review it right now, and after with Eric, we will be ready for answering to your question. We have tried to make a movie, a simple movie, where the story is rather complex. So I hope it will help you to understand where we are today. And it would have been easy for us, Eric and I, to stay in the room and not to speak about it. We have decided to speak about it in front of you. When we work with Eli Offshore, it's safety through collaboration. So it's what we want to do with you is safety through collaboration. We want to share as transparently as possible when safety is at stake. So I think we can start the movie.
On the 29th of April 2016, the H225 LNOJF helicopter operated by CHC Helicopter suffered a fatal accident near Troy in Norway. Each and every one of us was deeply affected. Understanding what happened that tragic day has been a #1 priority for Airbus Helicopters ever since. We have made all our human and material resources available to investigators to enable them to complete their work as quickly as possible. Initial observations revealed that the rotor had separated from the cabin. In response, we began by listing all the possible scenarios that could have led to such an outcome, even the most improbable ones. One by one, every branch on the fault tree analysis was put to the test in order to confirm or rule out each hypothesis. We drew on all the information gathered by the investigators on site to piece together exactly what happened. Each and every detail was taken into consideration. We also used complex numerical models in simulating different failure modes, comparing them with observations of the actual parts. In the meantime, we considered and examined a 2009 Super Puma accident that bore similarities. Finally, we carried out about 2,000 hours of testing in dozens of different tests, the aim being to reproduce the failure scenarios envisioned and to identify which one actually occurred. In total, more than 370 people were called upon during the course of a year. Throughout the official investigation led by the Norwegian Accident Investigation Board and supported by Airbus helicopters, we were able to identify precisely the sequence of events. The origin was traced back to the inside of the main gearbox, a key mechanism in the aircraft, as it transmits power from the engines to the rotors, while reducing rotational speed from 23,000 RPM to 265 RPM for the main rotor. The inside is a series of reduction stages comprising gears manufactured using the finest material and surface treatment technologies and in line with the highest quality standards. The second stage, epicyclic gear train, comprises a sun gear, 8 planet gears, a planet carrier, and a fixed ring. Each planet gear contains 2 inner races, 2 rows of rollers, 1 outer ring. It is inside this ring that the failure began, with an initial and very limited spalling. Unexpectedly, this very limited spalling gave way to a crack, which then spread until the planet gear split in two between 2 teeth. The space between these 2 teeth grew, causing a collision with a tooth on the sun gear. The planet gear broke instantly. Pulled by its own inertia, the main rotor caused the top section of the main gearbox to shear off and separate from the structure. Let's go back to the beginning, however. How could such an accident have happened? The potential contributing factors were identified, and safety barriers were put in place to eliminate their reoccurrence. One of them is the non-detection of very limited spalling. Spalling is a normal degradation of bearings that remains acceptable up to a certain amount. This is monitored with magnetic plugs that collect the metallic particles. In the case of LNOJF, the defined practice of particle detection was not sufficient to reveal very limited spalling. We have therefore improved this practice of metal particle detection. The frequency of inspections has been significantly increased. Stricter removal criteria have been put in place regarding particle sizes. Detection methods were completely overhauled and now include the latest generation magnetic plug with increased performance. Another potential contributing factor is the phenomenon of fatigue. Some metal parts subjected to high repeated stress have a defined number of cycles before their possible failure. Airbus helicopters therefore defines a maximum operating time for each part. In 2004, Airbus helicopters defined a maximum operating time in accordance with the certification requirements. In 2017, based on the learnings from the accident investigation, this maximum operating time has been reduced by a factor of 4. Another potential contributing factor is linked to the design of the planet gear. 2 suppliers manufacture these planet gears, and their designs are not 100% identical, even if both match the technical specifications. The second creates greater contact pressure and was used in the LNOJF's main gearbox. This planet gear has now been prohibited outright. The only planet gear now present in our Super Puma family has registered 22 million flight hours without any outer race spalling having been detected in normal conditions. Another potential contributing factor is external damage occurring to the main gearbox. Before being fitted onto the helicopter, the main gearbox in question sustained a fall during a road transportation accident. It has been decided to withdraw from service any main gearbox having suffered a shock, a lightning strike, a hard landing. In addition, we put in place a series of initiatives to improve the shock resistance of the main gearbox during transportation and to better report back any unexpected event. Sensors that capture parameters such as temperature, pressure, altitude, lighting, inclination, and shock level have been placed on the main gearbox, and previous history of the part can be closely monitored. The packaging for the main gearbox now includes highly visible stickers that change color if the crate sustains a certain level of force or shock. The last potential contributing factor is a contamination by impurities finding their way into the main gearbox during maintenance, which then could have created damage in the planet gear leading to spalling. Additional measures have been put in place to protect the main gearbox during maintenance operations. and disassembly of main gearbox modules can now only be performed by an Airbus helicopter's certified maintenance or repair centre. The safety barriers put in place are aimed at eliminating the contributing factors to the LNOJF accident. Based on these measures, the European Aviation Safety Agency and all aviation authorities worldwide have approved the return to service of the H225 and the AS332L2. Any accident is one too many, and in order to reach our zero accident goal, we are committed to continually improving. The investigation underway led us to thoroughly review and rethink many of our quality and safety processes, not only for the Super Puma, but for all helicopters in the Airbus range. One example is how we are working on improvements for handling and tracking dynamic components. This includes developing better solutions for documentation, repair feedback, and digital solutions for better traceability. Furthermore, taking what we have learned from these investigations, we have gone back and checked the stress analysis for all our aircraft. We took additional steps and applied the same strict standards on planet gear bearing contact pressure to our other helicopters, which led to the removal of 2 types of planet gear as a precautionary measure for the Dauphin family. Finally, we have launched a research program to innovate how we analyze vibrations. The vibration detection systems on the H225 are used to collect and analyze critical data to optimize the helicopter's availability and safety. We are working in partnership with leading university research centres on the detection of occurrences such as spalling and cracks. We already use vibration as a way to detect damage in fixed gears, but applying these methods to moving gears, such as epicyclic gear trains, does not exist. It requires the use of new sensing technologies and complex signal processing methods. We are seeing some promising developments in this field. All this leads to improve our safety culture. To you who fly in our helicopters every day to complete your missions, and to you, our employees who test each helicopter before it's delivered, your lives are invaluable. We are doing every day everything in our power to learn from this experience and to ensure that the Super Puma is flying with an increased level of safety. Just as we rely on your continued faith, you can rely on our unbending commitment to safety.
Okay, so now we suggest you to have some question internally before going to the Slido. If you have a very, very short question, let's go for the question regarding this session, please.
Good morning. Miguel Fallewen from Babcock, Spain. We operate over 150 aircraft, one of them is a 225. First of all, I'd like to thank you for the transparency. If I may say, in our operator, we have gone from 4 accidents per year to 4 years without accidents, and transparency has been a key for it. So in that respect, I'd like to ask you, in the video you mentioned the stress analysis review. What has been the outcome of your stress analysis for the whole fleet?
So I just mentioned in the movie, considering the contact pressure on integrated races for bearings of planet gears, the measure we have taken on Super Puma to a particular threshold have been analyzed with the other platforms, and we have leading to the conclusion that a precautionary measure we remove from services some gears on the Dauphin family. And for the other platforms, we concluded that based on the actual knowledge, there is no need of precautionary measures.
Jeremy Lieber, aerospace consultant. You said you compared this accident with a similar one in 2009. Did you find any commonality? And if so, what?
We had an accident in 2009, which bears some similarities, but also there was a lot of differences. Especially in 2009, when we had the accident, there was a kind of consensus that it was a normal spooling based on some engineering analysis. So it was a normal spooling. We modified the design of our main gearbox. There was some magnets between the main module and the epicyclic module. And so after we knew at this after these accidents, we took reasonable safety measures. So finally, the outcome of the scenario are similar if you look at the 2009 accident and the 2016, but there were significant differences, and especially what was called limited spooling is something that we didn't see on the 2009 accident.
Another question, please?
With regards to the spalling, is there a SOAP program being used?
So we are discussing among experts since not to hide it, decades on the SOAP, on the efficiency of a SOAP program. Here we are talking of particles of a size where we consider, and we have an agreement also with experts, that a SOAP program will not detect them. Here we are in a particle degradation mode where particles are generated by the bearings and which are not very small ones. Yeah? Here we are talking about limited spalling in terms of amount of particles, not of the size of those ones. The SOAP program is more designed to detect wear on parts which are related to the teeth, for example, where you detect wear on the teeth. We consider that the SOAP program will not have detected this particular failure scenario.
Thank you.
Hello, Darya Grak from TAI. I want to ask, did you change any analysis methodology, fatigue analysis methodology, or any particular test after this accident?
Can you precise your question, or is your question related to the standard we were using for certification of the gearboxes, or for the production, yes, or for in which stage?
For example, there's an endurance test for the drive system.
Okay.
So did you change any hours or anything else?
It's questions which we are dealing also with EASA, and we welcome and participated to the group which is related to transmission, which is led by an EASA expert. Just let me just explain that all the certification testing of these gearboxes, which have not been changed in the regulation since this aircraft has been certified, have not revealed this particular phenomenon. So we are conducting several testing and evaluations, which was mentioned with in the film, not directly, but saying cooperation with research bodies and entities to better understand this particular phenomenon. Today, the requirements on certification level have not changed, but we foresee that there will be a need to let them evolve, to take into consideration those learnings for the whole rotorcraft industry. And just to come back to the SOAP, we continue to work on these particular aspects, not saying we exclude it completely.
Hello, Andy Lyons, Ceres Energy. can understand on an existing design it's really difficult to change things because it's you're committed to design. But given in the case of a planet gear where you've got 8 of them, and then the failure of any one can lead to the end result, in the future, would you consider integrated bearings as suitable for planet gears? Or is that something you might back off from? Bearing in mind that your planet gear has an integrated bearing where the rollers were rolling directly on the gear part.
So a short answer to a question where you can debate during very lengthy, and as I'm not a transmission engineer, I will give you the very high-level answer. Your question could be summarized like this: why are we chosen to have integrated bearings and not to have bearings with an outer ring and a separation with the gear itself? The two designs have advantage on one side and we say topics on the other side, which needs to be controlled correctly. When you don't have an integrated bearing, you have a fretting between the gear and the outer wing, which needs also to be addressed. So frankly, yes, we consider that integrated bearings, so with the outer race part of the gear, is a design which we continue to implement on gearboxes with the knowledge we are taking from everything we have launched since this accident.
Okay, I suggest to stop for the time being this answer and question. We will come back later on, so we will proceed for the next presentation, and we will come back after the 2 presentations to the question and answer again. Thank you.
So I am now inviting on stage François Lassalle, and he will present on the subject of safety intelligence, and more specifically the safety intelligence data system that LE Offshore is putting together for the benefit of the oil and gas offshore operators. François is operation director at LE Offshore and also a pilot and instructor.
Good morning, everybody. I'm going to start my clock because Larry did 18:09. I'm going to try and get it exactly at 20 minutes. Little competition going. Let's see if I can do this. There we go. All right, we've got my slides going. Let's go back a little bit to the first bit. LE Offshore, global collaboration, frontline results. You heard Patrick Key stand up this morning and talk about the fact that we've got to do this all together. Nobody's going to do it on their own. And that's one thing at LE Offshore we've recognized very quickly, is that we're going to be much more effective if we do this together and improve safety. And so I'm going to talk about our safety intelligence data program, why we called it safety intelligence, to help all of the operators in our community and all of our stakeholders in our community, not just the operators, make intelligent safety and business decisions. But also, I want to talk a little bit about the why. Okay, so a good story and a very powerful story. So a lot of you have heard, I've told it several times, so a lot of you probably heard it already before, so I apologize, but it's a powerful story, so I want to tell it again. And that is the fact that it was relayed to me when I joined LE Offshore 2 years ago that one of this person's dispatchers was dispatching 2 flights. One was a fixed-wing flight, and one was a helicopter flight. And it was from A to B over a stretch of water. And he sat there and watched the passengers walk out of the fixed-wing into the helicopter. Now, the people of the fixed-wing aircraft all walked out in their shorts, T-shirts, and flip-flops. And the guys walking out to the helicopter walked out in their goon suits with their emergency breathing equipment and their aids and all their survival equipment like this out to the helicopter. He said, why is it like that? Why should it be like that? Why can't it be like the fixed wing industry in terms of safety? Why? Because you're 4.5 times, and don't quote me on this, I think it's about 4.5 times, 4.5 times more likely to be involved in an accident in a helicopter than you are on a fixed wing. So Helios Shore is about changing that. So the why. The objective is to bring these people home every day safely. In a nutshell. Why else are we going to do it? We need to be able to train the industry. We currently don't have an efficient way of training the industry. So what we've done is we've taken the studies done by EASA so far, and that's basically our leading light and giving us direction. But we need to be able to train the industry. Why else are we going to do it? Well, we have a strategy, but we need to drive that strategy, but we need data to drive the strategy. Because for a long time, a lot of the strategy has been based on anecdotal evidence and what people think are important. And more importantly, it takes money to make everything happen. We need to drive our resources. So if we're going to have people effectively buy into what we're trying to do, help pay for things that we're trying to do, we need data to substantiate that. And of course, this is the key, right? There's a lot of very, very intelligent people in this room. And when we're presented with a problem, a lot of people will sit around a table and they'll come up with a great solution to that problem. The solution could be standard operating procedures, it could be manuals, it could be guidance material, it could be training videos, it could be a whole myriad of things. But what we do is we do those things, we produce them, and then we launch them out into the community. And that's where we stop. We're not measuring that those things are having an effect on the front line. So how do we know that our resources are having that effect? So we need it to measure the actions that we're taking are having the effect on the front line, and we need to be able to measure that. Okay, so what do I mean by trending the industry? So this graph came out of our request for proposal, which went out, and it basically draws a picture of where we are now. Phase 1 is complete, right? So we're up here, we collect summary reports, accidents and incidents, and we link them to actions and events, and then we define the action plan with the CDF. That's where we sit today. Less diagnostic, more reactive, more analytical. It's all about the what happened, right? And let's fix it. But we want to go beyond that. We need to go beyond that as an industry. And so we're at phase 2 now. We're very, very close to launching phase 2. We need some context around these things. We need accurate taxonomies. We need to know what the causal factors are. We need to start fusing multiple sources of data together to be accurate. And we need to start being more predictive. But waiting for the accident to happen and then coming up with a solution is the old way of doing it, not the way that we should be doing it. And then obviously, in about 24 months, possibly 3 years from now, we're moving into phase 3, which is big data. And that's going to fuse multiple sources of data where we can actually become more diagnostic, more proactive, and more action-orientated. And I'll show you a slide earlier, but ultimately what we want to do is to become predictive. The why. We need to be able to predict the accident long before it happens. We do that, we've already started. This is a screenshot of our phase 1, where we're collecting summary reports from our operators, and we're feeding that into the system. But at the moment, it's based on what people choose to report, because we're getting the industry used to reporting. An industry that's not really reported collaboratively before into a system that they don't own. So as a result of that, we're getting some great results from it, but the problem is we can't trend it, because we've got no rates, and it's what people choose to report. So we're moving beyond that. So how are we going to get there? What's our strategy? Well, a key to our strategy is collaboration. As we talked about, Patrick talked about, collaboration equals frontline results. And what we've done to build our data program is we've teamed up with General Electric, Tonic, and NLR to help us. And we effectively have a team of professionals sitting around the table now that have done this before in multiple walks of life, both in fixed wing and other industries. So we're not reinventing the wheel. We don't want to reinvent the wheel. We want to learn from how other industries have done it. What's going to drive us? How do we know a starting point? Where are we going to go from here? I don't know how many of you have seen, hands up who's seen this before, this safety performance model. Come on, stick your hands up, don't be shy. 4, 5? We're not doing a very good job, thank you for the support. Right, so this is basically a hybrid. This is the Helios Shore Safety Performance Model, and this is a hybrid of the safety risk portfolio from EASA, looking at a 25-year study, And we've highlighted the top three: system failure, aircraft upset, surface obstacle conflict, and then down here the enablers, the things that are going to make it happen. So on this side, that's the accident. These are the boxes that we've got to be good at to prevent the accident from happening. And then, of course, we have survivability down on the right-hand side. So if you were to look at this like a bow tie, that's really what you have. And so we're focusing on these ones, right? Because we don't have the resources to tackle everything at the moment. So that's our strategy. It's going to drive us. So we're not saying to operators, here, there's a big pipe, connect it into your operation and download all of your data. Because you know that's not going to happen. We know that's not going to happen. We need to be very targeted about where we're getting the data from. So we use this to drive in a particular direction, be very specific about what data we want, why we want it, what's in it for them to share their data with us, and what they're going to get out of it. This is where we're going to in terms of phase 3. The circle in the middle there is the Predix platform with GE, but ultimately what we're going to have is large operators, small operators, and all of our other stakeholders sitting in here, right? Because all of our stakeholders need to get hold of this data to make their business and safety decisions. And that'll feed into an aggregated system and be able to spit out a dashboard. I've made it look very simple. It's much more complex than that. Why is it much more complex than that? Any suggestions? No suggestions? The technology is the easy part. What's the difficult part? What? The human, yeah. The human part. The acceptance that sharing data is not going to penalize them, but we're going to do better as a result of it. So what we're trying to create is a cultural revolution. We're not trying to reinvent the wheel. It's a cultural revolution that needs to take place. So we're going to start doing it baby steps. Here's that diagram I was talking about earlier, where you have ultimately where we sit down here at this bottom end, right? This is where we are today, and where we need to be is up here. And the only way we can do that is if we are collecting data and sharing data collaboratively. A good example of that is our flight data management, our FDM working group. The FDM working group decided we'll just focus on one area of flight, the approach phase of flight. Let's go into our FDM programs and let's extract the event sets that we're looking at, the triggers that we're looking at. Let's extract that information and compare it amongst ourselves. On the same aircraft type, flying to the same platform, guess what? Each operator is looking at something completely different. Why? Well, they all think they're looking at the right thing. But when you benchmark yourself against the industry, all of a sudden you're going, well, why are they looking at that and we're not looking at that? Why are we looking at this and they're not looking at that? So it starts to raise those questions. So the key is, what does good look like? The fact is, nobody truly knows. Is anybody here in this industry, in this room, that's currently benchmarking their own operation with a global industry or even a European industry? Anybody doing that? Stick your hand up, because I'd like to talk to you afterwards. We'll have a chat afterwards. I'm interested. Anybody else? Nobody else? So what we're offering is a unique opportunity for our members to collaborate. Now think if you own 2 aircraft compared to 500 aircraft. What is the possibility of you seeing that accident coming? What is the possibility of you seeing that data alluding to the accident before it happens with 2 aircraft? It's impossible. Now, if you're in a pool with 1,000, 2,000 aircraft, the amount of data that you get exposed to is a lot more. So you become part of the bigger picture. So how are we going to do this? How are we starting this? Well, we need to identify 3 areas of focus, right? And why did we need to identify that? Because we need to demonstrate early success. We need to demonstrate the concept. We need to demonstrate that this is very powerful. We need to trigger those emotional responses to something that's so powerful, we're just going to say we can't live without it, because we really cannot stand here publicly and say, we're 100% safe, we know what we're doing, and we have all the answers. Nobody does. So we're establishing baselines, we understand our exposure, we assess and improve reliability, and we understand and develop data management aids. We need to know what the effectiveness of the program is, and we need to create momentum to advocate for change. Create momentum to advocate for change. What was that we were talking about? Yeah, the perception of it. The perception that if I put my data in, if I air my dirty laundry, it's going to come back and bite me in the backside. We're not reinventing the wheel. This has been done before, right? So it's not going to, and that's why we've got to make that cultural revolution happen for people to understand that it's not going to. So what are the 3 areas we're focusing on? The first area we're focusing on is a directed study in the maintenance sector. We've already collected this data on our return to base study. Everybody know what a return to base is? Well, stick your hand up if you don't know what a return to base is. So if you get airborne from the airfield and you're flying out to an oil installation and you have a problem, the pilot decides to return to base. And all of those are logged and recorded with the operators. We've collected about 6,000 events. And so what we're going to do is, because we already have that data, it's less contentious data, and it's good information for us to be able to put into the system to demonstrate the proof of concept. We're starting with that. It's not the answer to everything, but it's a good starting point. What's the other area we're going to focus on? Approach path management. This is a screenshot of our approach path management guidance material, and it's looking just at the approach phase of flight. So remember I said earlier, we're focusing the approach phase of flight. All the operations that are sitting in the program are going to go back and they're going to interrogate their FDM data based on this criteria, not their own triggers. Remember, they're all completely different. And they're just going to focus on this, and we're going to pull that data into the FDM, into the data program, to see if we can actually get some decent results out of that. But we just want to do the early success in this area. And then ongoing performance monitoring. How well do we know we're doing? Are we collecting rates? What is our accident rate? Are we collecting cycles? Are we collecting hours? The answer is no. So if we can do that, now we've got something to measure against tangibly. So that's going to be one of the third key area that we're focusing on. Right, resources and collaboration. Great quote from Henry Ford. Everybody seen that before? If everybody's moving forward together, then the success takes care of itself. And that's what Patrick Key said effectively earlier. That's what I'm saying now. And so we are making sure that we're completely aligned with everybody that is doing this. So the Data for Safety program, a massive thing. Everybody goes, oh, well, you're doing that, and EASA's doing that. It's the same thing. It's completely different. We're on a global scale. EASA's European focused. We're in offshore operations. EASA's covering a whole broad band of rotorcraft. EASA's focusing on fixed wing earlier, and then coming to the rotorcraft world. By that time, we're going to have enough data to substantiate a lot of our stuff and share knowledge with EASA. We are currently not building a platform in isolation. We're building a platform that'll be able to speak across platforms, right? So we want open communication with the EASA and alignment with the Data for Safety program. So we have ongoing conversations. We're working with the EASA to ensure there's no duplication of downloads. So we're not saying to an operator, well, you must download all your data to EASA, now you must download it all to Helios Shore. So we'll set up agreements where that doesn't happen. We'll establish agreements on the sharing of information, which is crucial, because obviously the information could go back to the industry. We need to be able to share that with EASA. Why do we need to share that with EASA? Because it assists in better performance-based regulation. How are we doing? How are we measuring against what we said we're going to do? And then, of course, the last one, there's robust coordination of use data and directed studies. We're working with Cliff Johnson at the FIA on the ASIAS Rotorcraft program. Everybody heard of the ASIAS Rotorcraft program? Nobody's heard of it in this room. No, not one person's heard of the ASIAS Rotorcraft program. Hands up, who's heard of the ASIAS Rotorcraft program? Not many. You're all shy today. Andy Evans, thanks. I could get the support from Andy. Thanks, mate. Yeah. To make sure that we're aligned with what they're doing and make sure our platforms will be able to speak. Flight Safety Foundation, GSIP, the Global Safety Information Project. We're aligned with them. They don't have a database, and they're not currently collecting data, and they're not going to do that in the foreseeable future, but they are building infrastructure around how to share information globally. So we are very much connected with what they're doing. Right, resource. How are we going to make this happen in a time where resources are limited? Any suggestions how we manage this? All right, we need the data program to demonstrate that our resources are having the right effect. But we need to get the resources at the beginning. It's kind of catch-22. But the good thing is that phase 2, we're talking about now, is funded, and we've got the funding to manage this program. So we've made good development there. Obviously, we've expanded from 5 members 2 years ago to now 108 members. So we have many more resources, i.e. human resources and other operators and stakeholders and members that are getting more involved with the programs in Hello Shore. And of course, it comes back to us being able to collect the data from those resources to move in the right direction. So what's our action plan? There we are. I talked about the early successes. The first one we got there is, obviously, I'm talking today at the Rotorcraft Symposium. And we've got HI coming up. We're going to announce a much more detailed roadmap at HI because we've been able to get the right brains together for the first time in the room. And we've sat down, we've thrashed out at least an interim roadmap. And the thing is that if you were to ask me how you're going to build this, and I'm sure there will be a question at the end of saying, well, how are you going to download the data? And you're going to get into those sort of technical questions. And I'm not the technical expert in this, because I've got the right team to be able to answer those questions. We know the bookends. We have each end of the bookshelf. But all the bit in the middle, we kind of have a vision of what that'll look like. But until you get the right people around the table and start having an open conversation about what can you do, what can't you do, what is your capability, you know, how quickly can we get that done, how quickly can we get the data in, how are we going to be able to produce it, how are we going to be able to produce it, all those sort of questions come out in those brainstorming sessions. So we're developing this using an agile process to make sure that we don't waste 6 months to a year developing something that's not going to work. We had 3 weekly intervals where each of those 3 projects I talked about will touch base every 3 weeks to ensure that it's going to be successful. If it's not, we cut that off and we go in a different direction. And that's to help us develop this in a quicker time frame. Obviously, we set ourselves 24 months to finish phase 2. Phase 2 is collecting of FDM, basically those 3 projects, to have them up and running fully by December 2019. And obviously, our conference in Italy next year, we want to be able to demonstrate with tangible dashboards and evidence what we're doing, the data we've collected. That's just a little bit of the program, but here's our roadmap, right? Very, very basic roadmap. Doesn't need to be more complicated than that, but we have all the entities with their very complicated project planning processes in between all of those stages. But for you folks, that's basically a very simple sketch of what's happening over the next 2 years with Helios Shore's data program. So, I got 1 minute 47 left. So I'm not doing very well, am I? I've got to talk nonsense for another 1 minute 42. Here goes. Connect with us, right? Connect with us on social media, because on our website, we've got a lot of resources. You can go and have a look at the stuff that we're doing and understand what we're doing in more detail. There's some downloadable stuff. There's some videos you can go and watch. Unfortunately, I'm in the video, so I apologize for that. But go and have a look at the stuff that we're doing. So please, comment, give feedback. That's very useful for us. I'll take questions afterwards, but thank you very much for your time.
Thank you very much, Francois. Have you seen a very passionate guy all the time? He's giving life in the discussion. So now, let's call another passionate guy. Andy, how are you?
Very good.
Andy Evans, Aero Assurance. Nice meeting you again, and have a very good success of you.
Oops, I'm going backwards. It was a good presentation. Thank you. I'll start by saying good afternoon, everyone. I have the privilege of following these esteemed gentlemen and being the last person before lunch. What a privileged position. What I'm going to talk about for the next, hopefully, 15 to 20 minutes is a potential opportunity in terms of human-centered design and rotorcraft flying controls. Okay. Oops, it's gone horribly wrong. There we go. See how we go. Other people have talked about going back as far as 1980 in the dim and distant past. I'm going to go back even further. I've done it again. I do apologise. There you go, you've seen the presentation quickly. I'm going to go to 1964. Back in 1964, Eric Newton was the Chief Technical Officer of what was then in the UK, the Accidents Investigation Branch. It's so long ago, no one in any other domain had even thought that even investigating accidents was a good thing. And Eric wrote a paper for the Royal Aeronautical Society in 1964, looking at mechanical failures of aircraft. And perhaps interestingly, one of the mechanical failures he discussed was the misassembly of components. You might think, how terribly old-fashioned. They didn't think of human factors back then. They just put that in a long list of mechanical failures, somewhere below fatigue and corrosion. But what was interesting is Newton was really pointing out that misassembly is not just a maintenance issue, it's also a design issue, by treating it as one of those things that designers need to consider when they design their products. It's interesting that in the paper, later on, he actually mentions Murphy's Law, which actually was derived from a real assembly error during a US Air Force test with some flight test instrumentation. But that's another story, and that goes back even further. My message here is you go back 2 or 3 generations and people understood that when you design something, you need to design to reduce or even eliminate the possibility for misassembly. Now, I'm going to touch on 2 case studies in the next part of the presentation. I've picked them simply because they are helpful at illustrating the point. The aim is not really to talk about either incident or occurrence directly. See if I can do this correctly this time. No. I'm a walking example of why human factors is an important topic to consider. There we go. Case study number 1 involves 3 light twin helicopters. I'm not going to mention the type. It doesn't actually matter for the purposes of this. This particular model of helicopter, these 3 were of an upgraded version. And in a period of, what we're talking, less than a year, 3 different helicopters in 2 different countries with 3 different operators suffered the same problem. The first one, you can see the wreckage here, was a fatal accident. The second helicopter ended on its side. The third helicopter luckily ended up the right way up after these occurrences. It's interesting to look at the number of flying hours since the last maintenance action. Now, I'm talking about misassembly and human-centered design, flying controls. It's interesting, compared to, say, misrigging a flying control cable, where if you don't spot it before you go and fly, actually, you're probably going to appear on a dramatic YouTube video within the next 60 seconds of flight. Historically, that's happened. Here, these failures, they're fast. You know, mechanical failures on rotating components of helicopters generate and happen fast. But you know, 3 hours, 10 minutes after the maintenance was done, that's enough to do a heavy hover, maintenance check flight, maybe position back and pick up your passengers. So these are quite high risk type of accidents. Let's try again. Yeah, change the interface controls now, much better. Now, in all 3 cases, the issue involved the Rotorcraft, the rotor swash plate drive arm. This little device you see on the left in 2 different photographs. The images on the right show how the lower link has been misassembled on the right-hand side. By doing that, that component now touches a little cup washer, and that is the source of a fatigue failure. Now, what I'll just point out in this image very briefly, because it's relevant on the next slide, is the bolts. Heads of the bolts are on this side, and you've got these little shaped washers under those, and on the other side are the nuts and their fastenings. We'll come to that in a moment. So the engineers who did this task had the maintenance data. I challenge you to interpret that data correctly in terms of working out which way round to put this particular lower component. The two red circles, that lower component is not completely distinct, arguably. I've marked up two of the washers, those shaped washers in red on the right-hand side. Again, it's difficult to specifically see that those are the shaped washers. So that's not a great clue. There's a couple of part numbers marked in yellow. Turns out when this particular document was examined, there was a couple of transcription errors in part numbers against IPC numbers. Not relevant, but another challenge for the engineers. The only really pertinent thing that jumps out if you know the layout is where the nuts and the split pins are, and they're both on the left-hand side. I, however, have given you the advantage of putting them in big green rings. So, in this particular maintenance task, was the maintenance manual clear? Well, I've given it 2 out of 3 on this one. Unfortunately, that lower component could be reversed on the later model of this particular helicopter type. Interestingly, A model didn't suffer this problem. Slightly different design, that link could only go in physically one way because it was offset slightly. Interestingly, the engineers, when they had the type training implied that the main rotor had not been changed when going from the early model to the later model. So they were sort of set up with the assumption they would be doing a task they were familiar with. There was also another visual clue that may have caused confusion. The earlier model had the part number embossed on the outside of the casting. The later model had it embossed on the other side. So if you were using that as a learned visual clue, it would encourage you to reverse the component. Now, of course, independent inspections should pick these things up. But in terms of sort of confirmation bias, if you're expecting something to generally be right most of the time, it's very easy, if it makes sense to the first person to do the inspection, for it to make sense to the second person. And of course, they'd never done this task before on this new model of helicopter. The 3 accident reports are a little bit vague on whether any kind of fallen-free functional test had been done. Maybe that would have picked up the contact with the cup washer, maybe not. The last line is just a quick note that after the 3rd occurrence, and to be honest, it was only after the 3rd occurrence that all the information was pieced together. The manufacturer issued an information leaflet and highlighted this particular challenge. Now, I mentioned 1964 before. Now, that was before I was born, perhaps surprisingly, don't laugh. Probably before anyone in this room started their aviation career. I'm pretty confident on that. But 1964 is an important year because 1964 is the year that the cert requirements that are relevant to this type of component were written. And for Part 27 and Part 29, they have not changed since 1964. Now, you might think that's because it's an excellent and mature and perfect rule, but perhaps we should look at the words first before we jump to any conclusions. Now, actually, the words are quite good. Well, some of them. It talks about designing to minimize the probability of any incorrect assembly. That's pretty good. But then in purple, also in yellow, it says, but if you can't design it that way, you can mark it. In the AC material, again, it does say, plus point, the preferred method is to make it impossible to misassemble. But then it says, in the event that incorrect assembly is physically possible, brackets, because of other considerations, you can use some markings. I'd be fascinated to see what people think other considerations might be. I assume it doesn't mean, it's Friday afternoon, long weekend coming up. That's good enough, we'll just leave it as it is and slap a label on. It's a slightly odd bit of advisory circular material. So we're working with quite an old rule. which is more flexible than it first appears to be. And in practice, there is evidence, there's some other events that I'm not going to discuss today, where actually when you look at it, after a misassembly, even the labelling hasn't appeared. So it does question how some of the compliance has been found in the past. Now I'm going to look at another example which does involve an accident, but I'm merely using this as an illustration. I'm not commenting on the accident itself. Firstly, I'm just going to give you a quick orientation to some controls. There's a big rod that goes that way, backwards and forwards. It turns a little L piece that rocks. That then moves another linkage up and down. Brilliant flying control stuff, really exciting. What I'm going to talk about in this example is the potential of variability in assembly. So it's not a square peg in a round hole type misassembly, but other variations in maintenance and assembly, as well as how inspectable things are. So this particular photo is taken from an accident report, and as I say, I'm merely using it to illustrate the configuration. Now, the good news on this one, you have got a little label on that particular nut to say, put it this way round. So labelling is going on. Now, this particular assembly, according to accident investigators, this is how it was found. So you've got an item, a fork end pinned at this end. You've got a eye end with a thread, which is pinned at that end, and the thread that goes in the tube is found outside. We have no more information on that in the public domain, but that's not really my interest. Now, what you've got in this assembly is a jam nut, a little nut there. Now, tightening that puts some preload on the whole assembly. That stops it vibrating. Good thing. At the time, originally, the instructions for doing this assembly talked about finger tightening, then tightening 1/6 to 1/3 of a turn. So there's some variability in the assembly between what I think is finger tight and roughly what I think is in that range of movement, and what someone else might do, or even what I myself might do on a different time at a different date. So there's some potential for variance. There's no repetitive inspection, or there wasn't on this particular component. There's no secondary locking. And really the question on this is, how would you do an independent inspection on this? You walk up to it, all the components are in the right place. Perhaps you can check it's not loose. There's no torque value, so you can't check for torque. Very difficult to inspect. So one of our prime ways or last lines of defense against misassembly might not work terribly well. Now, things have changed on this design since, but it's worth noting that design has been in service for many millions of hours without any prior adverse experience. So what I'm suggesting is, as well as orientation and how you and the complete build with all the right components, there are other factors maybe to consider. So my very brief conclusions and a little opportunity here. Now, I would argue the certification requirements have a sort of loophole. They're focused only on an orientation, not adjustment. It appears the approach to compliance may be a little bit variable, not necessarily between manufacturers, just between different components across aircraft. Now, there have been a number of techniques demonstrated in the past looking at assessing the risk of misassembly errors. So a number of techniques have been used. For example, Sherpa is a technique that was popular and is popular in the nuclear and rail industry. That's been tried on helicopter components at least 17 or 18 years ago, quite successfully. Some other organisations who are on the stage are working on some research at the moment on human-centred design and human reliability risk assessment type processes, which have good potential to help look at these types of assemblies and identify the possible ways they can fail and help improve designs. In terms of rulemaking, there are 2 rulemaking tasks on the EASA inventory, both of which could, if the agency was minded, start to look at this particular area. 712 is looking at safety assessment processes for rotorcraft. That one's particularly interesting because in the previous RMT looking at aeroplanes, they did actually have a look at the fixed wing equivalent of that flying controls rule and made some improvements to it in an MPA. I'd argue that with the risk of misassembly in rotorcraft, I would say be even higher because of the larger number of components that could be critical. Perhaps we have the opportunity in rotorcraft to do something a little bit more advanced and maybe be ahead of the fixed wing community on this. There is another rulemaking task, 713, which is about HF-caused rotorcraft accidents. Now, that particular task at the moment is written primarily around cockpit man-machine interface issues, but potentially that rulemaking task has the potential to pick up this particular subject. My final comment is, just remember that maintenance human factors is not just a maintenance problem. That's all I have to say. Thank you very much.
Thank you very much, Andy. So now I suggest starting the question and answer from the room, and then we will move to the Slido questions. So please, have the first question. Let's go.
Robert Grove Garmin, a question for Francois. Now that you're collecting data from all over in different parts of the world, does the data look the same from the different places you're collecting, or do you see differences in it?
Yeah, where did that question come from? Over there. Sorry, it was difficult to hear. You were saying, are we noticing a difference in the data that we're getting so far?
Yes, and now that you have locations where you're collecting data from various parts of the world, is the data that you're collecting look the same from the different places that you're receiving it, or do you see regional differences in the way the data looks?
You know, there is, but only when you look at it, and you're not looking at it objectively, because the problem is that we have right now is that you can't trend that data. So when you look at it, it could be misleading. If you look at it and you go, oh goodness me, there's a particular issue in this area or region, and you start trying to jump to conclusions as to why. And that's why we're trying to move to stage 2, because stage 1, which I showed you with that dashboard, is really only collecting that summary information. You know, an operator fills out a report, they had an event, fill out a report, submit it to us. We look at that homogeneously, but then we can't trend that data. So that's the conundrum that we have. We're not measuring it against a rate, and we can't measure it against any regional differences because it's just what people choose to report at the moment. And the whole idea is to get people used to reporting. That's really the baby step we've taken there.
As follow-up, I guess what I was looking for was, do you see that cultural differences in the way things are reported affects the data that you're getting from different areas?
Definitely. Definitely. That would, you know, culturally around the world, operators will report based on the relationship they have with their oil company, for example. You know, they're scared of retribution, so they won't report a particular thing. But when we go and have a sidebar conversation, they say, this is really important to us. I said, but we need the data to substantiate it. We're going to put resources there. No, but this is really important to us. We're too scared to report it because we feel there'll be punitive action contractually against us if we do. So, you know, when you get into anonymous reporting and you get into a sort of MOR situation where people have to report that stuff and it's completely anonymous, it takes that political relationship out of the equation and will help us. So that's why we're hoping phase 2 is going to be much more proactive in that sense.
Okay, let's go for another one. Okay. So, once more. Yes, Elisabetta?
Elisabetta Dalla Benetta from the European Helicopter Association. It's a question for EASA. Is there any legal constraints that would prevent EASA using a database coming from an external entity? Just referring back to the project from Heli Offshore. They're collecting all this data. Is there any problem in, stamping on behalf of EASA this database and consider it as, real usable?
That's a valid question. What I can tell you is that we are going to use these databases as they are. So we are aligning with Heli Offshore in the framework of data for safety projects to make sure the systems are compatible. The point is that Heli Offshore is collecting offshore operator specific data. We want to collect all operator data. And of course, maybe 99.99% of the offshore data will come from Heli Offshore database. And the objective is not to duplicate the effort and not asking dual reporting from the operator. That's very important. I think that, let's be clear on that. We want to avoid, and at any cost, dual reporting. So taking benefit of Heli Offshore work or other association work that are going to, like in HEMS, for instance, that we could have a similar approach. Now, what we are interested in is really collecting all operators' data. And I must say, especially the single aircraft operator that are non-commercial and isolated in the field somehow, where we have very, very, very limited data on. And what we would like to do is to really encourage this operator to feed the database. We need to find the right incentive to do so, because and I think what we could do and where we could add value with this data for safety project is to provide to this operator a feedback on a SMS for their operation, a safety management system, because when you are a single aircraft operator, or even 2 or 3 or 5, you don't have the view of what could potentially go wrong. Now, when we collect this data for each and every single operator, and if I take Airbus helicopter data that been provided, I think 80% of your operator are single aircraft or less than 5 aircraft operator. It does not make sense to make a SMS on one machine, one type of operation almost on yourself. You need to have a broader view, and I think that's what EASA could add value for this kind of operations. So just to make it as a conclusion, we will, of course, work together with bodies, associations that are collecting data, not duplicating the work, using their data, making sure upfront that the systems are compatible, and after it's only a matter of routine IT stuff. But we want also to really concentrate on the lower end of the operations, where, as it was mentioned early this morning, we have a huge gap in safety, where it represents almost half of the accidents we are facing yearly since 10 years, and where we have limited leverage. If we can, via this reporting, exchange of information, collaborative approach, make sure that everybody is aware of what's going on first, because it's not easy, and changing the culture also of the all stakeholder, it would make already a big change.
Can I add to that, Elizabeth, to substantiate what David's talking about? I think that's where EHA is going to play a crucial role, because it's easier for us to obtain the data from the big operators, right? It's much easier for us. They have the technology, they have the resource, I think the real challenge is when we start to ask the smaller operators, the aerial work guys, the HEMS guys for data. It's going to become a challenge because there's a resource involved in that. But we're hoping that what we're doing by laying down the foundation in Helios Shore is something that, as part of EHA, as Helios Shore is part of EHA, that's the information that we share with the EHA. So when we start to have a conversation with the Data for Safety program, this is where EHA, Helios Shore, and EASA are linked collaboratively. It's going to help us actually develop because we've done it before. So we're not going to go and reinvent the wheel where we do the same thing. But we need to start somewhere, and the offshore community is the natural starting point for us.
Any other questions in the room? No? Let's move up to the Slido questions. I guess, Larry, the first one is for you.
Yes, will changes to occupant protection standards increase the certification occupant mass requirement from 77 kilograms? We're not sure exactly what the ARAC recommendation is going to be. That will be received sometime in January. They focus primarily on crashes and fuel systems rather than the structural aspects, dynamic seats, and so forth. But I would be surprised if they addressed this particular issue. It wasn't part of their tasking statement. We'll just have to see what the recommendation says. Next one there may be for either one of us, David.
Yes.
In light of an improved collaboration between FAA and EASA, is there a plan to harmonize acronyms? I think when it comes to the airworthiness standards themselves, CS 27 and 29, I think we have a lot of commonality. When it comes to the various working groups and so forth, probably not.
So yes, we try first to harmonize the regulations. Second step will be probably the acronym, but I agree there are too much in the field. That's for sure. Next one, human-centered design. Is EASA planning to include maintenance human errors related requirement to the CSs? That's a good question. So in the presentation from Handy's, I guess we have a human factor, but it's not maintenance related so far. Handy, sorry. It's more cockpit related, and the 1302 requirement as done in fixed wing, which is very much missing in the rotorcraft area at this stage. So that's what this rulemaking task is about. But I think nothing prevent work on the maintenance related aspects. As I said this morning, we need to really raise the safety barriers where they are the most effective, and maintenance is definitely one of the key areas in the rotorcraft industry. Larry, I think the next is for you on the CFRS.
Just jumped around, I lost it there. What is the position of the FAA about the CRFS and newly manufactured and in-service helicopters which have not certified crash-resistant fuel systems? We think the equipage out there is inadequate. We think we need to do something with newly manufactured. You need to start somewhere. So we do think that newly manufactured rotorcraft need to do better with respect to increasing crash-resistant fuel system equipage, and I think the recommendation will reflect that. Regarding the in-service aircraft, as I mentioned during my discussion, we can do newly manufactured. We've got a 1% turnover per year, roughly. It will take a very long time to make a dent in improving the safety record if we don't do something about the aircraft that are already out there, the existing aircraft as well. So I think we need to address both those areas.
Yeah.
So I take the one on H225. So I read the question. Both alternative bearings fulfilled our specification. What are our lessons learned from design processes, make or buy processes, and our supply chain? Related to make or buy processes or supply chain, the lessons learned was that they worked correctly. So in the course of the investigation, we didn't find out any deviation in the supply chain and production of those parts. Related to design processes, the question is related to the reliability of those bearings. And when degradation scenario is considered, like being spooling, looking at the knowledge we had at that time and the knowledge we have today, we will include the knowledge we are gaining in the actual research programs because we are on research level. Rolling contact fatigue on integrated bearing races is at a research level. We will integrate it into the specification. So design processes will be influenced by outcomes of research on this.
Maybe François, question.
That one there, that last one that was there, was about data from small operators, SPO. Was that the question? I think I saw it earlier. I'll try and answer that as best I can. Helios Shore earlier this year announced that we are expanding our membership from not only the oil and gas operators, but also the wind farm operators. There's a lot of expansion of this industry. And these guys are operating a similar aircraft type in the same environment, and it doesn't make any sense in them going off and doing their own thing when they could be part of the Helios Shore program. So there's a lot of similarities and synergy there. And also to include the search and rescue community, non-military, but the search and rescue community that supports at this stage, we've only just started the group, that supports the oil and gas industry. So it's search and rescue, oil and gas, and wind farm energy. So there are small operators. We have small operators that are members of ours. And the HFDM working group is creating the FSIG. It's the Flight Data Sharing Implementation Guide, and that's going to allow all the rules, regulations, protocols, what you need to do, how you need to get involved for those operators. So there will be the templates and the structure in that environment.
Just before, human-centered design. No, that was the case. It disappeared. So the last one. Will the accident of H225 have impact on regulation for chip detection system? This accident obviously has led to a lot of activities, and we have set up dedicated groups to tackle the overall gear design. And this includes also chip detection system, but not only. So to tell you if that it will be an impact, at this stage it's still very early, but at least we are working on it together with the manufacturer. And it's on the whole, all the aspects linked to gearboxes, thanks to a working group we've set up with industry as a whole also, not only Airbus specific, to see what could be improved in gearbox designs and also a safety barrier associated to that. It's chip detection, oil cooling, and stuff like that. Andy, I guess it's...
Yeah. Thanks so much. I'll pick up the question that's, I think, in yellow. So that's talking about what are the main design rules which could significantly reduce human errors during maintenance tasks. And I think really there's an opportunity to be holistic and look at a wide selection of approaches here. The particular cert rule I put up earlier was very specific to flying controls and their assembly. So one approach would be to put particular requirements in against individual systems, and maybe there are other systems which are as critical and sensitive to misassembly. One example might be the main gearbox oil system. If accessories, chip detectors, etc., aren't sealed, there will be a loss of lube. So there's a potential to go down that quite specific route. A better strategy might be a more general requirement that did apply to critical components. Whether that should be limited just to assessing the process of assembly, whether it should be specific to certain features that would be expected, who knows? I think there's a lot of good debate that the right people could have in a working group developing either regulations or just good industry practice on this topic. I think it's probably worth Francois explaining there are things going on already.
Yeah, just to put a bit of background to what Andy's talking about, there is, which Andy's obviously involved in, Helios Shore has a program. I showed you the top of the list, our safety risk portfolio. The top of the list was system reliability and resilience, and that's one of the things. It's not just a part breaking, that is the human-machine system. So in other words, it's the human interface with the maintenance aspect. And we had a very successful meeting in Dallas earlier in October. Gilles, when did you come? October? So all the OEMs came and they gave a presentation. We talked about the top 5 issues that the operators, we collected that data and we shared it with the OEMs, and they came and had an opportunity for us to discuss openly with them the top 5 issues. And it's something that the industry recognizes it's an area of focus. We've spent a lot of time investing in human factors pilots, but not a great deal in terms of design and maintenance. So we've created this. We're working closely in collaboration with the OEMs on the human modes and effects analysis program, and we're hoping to be able to create a tool out of that that will be able to go back to the OEMs and the OEMs can work with in terms of human factors and design.
I think there's no more questions on the Slido, so I would like to thank all the presenters for their performance. And then I will let Jean-Marc giving you the instruction for the lunch. I guess it's a big part of it.
Thank you very much. Just before having a lunch break, a few information. So this afternoon we will restart at 2:30, but we will have 2 different sessions this afternoon. One session will be the airworthiness in that room, Ball 2 room, and the second one will be on the side close to this one, to the operational parts. So you are invited to decide which one you prefer. This one is the biggest room. The other one is about 100 and something more available seats. So just decide what you will prefer. Regarding the lunch break, the lunch will be at the end. When you leave the room there, you will have to turn to the right-hand side, and we will have different small rooms. You will not have only one room for lunch. You will have different small room for lunch. So I invite you now to go there and to start and enjoy your lunch. We'll be back on the room at 2:30. Thank you very much.